Hello, good morning and good afternoon, everyone. Again, I would like to welcome all the conference attendees to our 9th ASCAAD International Conference. It was a great dynamic kickoff for the conference. This is really great. My name is Zaki Malassi, and I will be the moderator for our first keynote session presentation. And I would like to dedicate a couple of minutes to introduce our first keynote speaker, Dr. Christian Derix from Derix Associates. Dr. Christian founded the first computational design group in architecture industry, and he is a global leader in computational urbanism and architecture AI. He is one of the early pioneers at the nexus of human-centric planning with generative design, data science, and machine learning. He is the founder of many number of state-of-the-art computational design groups and consultancies, for example, at Aedas, at Bagot, and also the urban systems of ERA CO. The work of this research groups has won numerous awards. To mention some of the examples, such as the President Medal, commendation from the Royal Institute of the British Architects, also the 2012 CTBUH Innovation Award for the Activated Façade of Bahr Towers in Abu Dhabi, and so on. He co-founded the Center for Evolutionary Computing in Architecture, for short CECA, at the University of East London in 2002, with Paul Coates, where many of the foundations where he had many of the foundations for the artificial intelligence and machine learning in space planning were laid. I'm looking forward for your talk, Dr. Christian. Your talk will discuss the trajectory of this research and development and applied projects across these 4 research and development teams and consultancy. And I think it would be great to see the output and the questions raised regarding the realization of the architecture without architects and how it leads to technologies for data-driven computational planning. Therefore, I'm very honored to introduce the keynote presentation by Dr. Derix, which is the Urban Planning Without Planners, the Opportunities and Risks of AI-Based Spatial Planning. Thank you, Dr. Christian. I'll leave the floor for you for the presentation.
Thank you very much, Zaki. Thanks for a great and detailed introduction. And thank you, Sharif, for the invitation. It's an honor to speak at this great platform, ASCAAD, which is the future, of course, of everything that's going on now. The Middle East and Africa, that'll be the place to be for the next 10 years in this domain. As most probably we're seeing at the moment, a lot of the AI being concentrated there in terms of planning. Yes, so when Sharif asked me to give a keynote at this conference in Cairo, there was a bit of an understanding that since I was positioned, luckily, at the very beginning of computational design, so at the origins, but also still working at the current edge in a way that I probably try to span the last 21 years that I've been in the field, 22 now, 1999. And I'll probably demonstrate some of the original work and talk about what we're doing now, where this might lead to. Just a summary again of what Zaki already talked about. Yes, I mean, I've always had, like probably some of you, a leg in academia. Originally, I was more an academic. I finished my PhD then to Vienna, where I also taught for 10 years nearly. And then, however, really concentrated more on practice for a while now, since 2015. And in practice, yes, I've set up in 2004, that was the first computational design group at all globally. And we even had to invent the name for it, which I'll talk about in a second. Invent the name computational design. And before moving on to setting up the research group at Bagot in 2014 called SUPERSPACE, forking out an urban computing consultancy for ERA in 2019, which was planned since 2018. And then eventually 21 set up my own firm with some of my associates and here from Frankfurt. I will, in this talk, cover 6 sections. The origins, effectively establishing computational design, urban computing, laying the foundation for it, somewhat academic still, then the kind of early generative master planning projects, asking yourself how to, then the next section, the urban users, how to use big data for urban planning, but then really asking ourselves, drill down a little bit more, who is the community in this kind of urban computing context, and an outlook on spatial AI. What type of environments are we creating? So just to give you a mind a little bit, whenever I ramble on for the next 45 minutes, that I'm somewhere within those 6 sections. The origins, establishing computational design. Yes, that's now doing inverted commas, so to speak, because it's literally the term itself wasn't there when I started. There were all sorts of terms. Of course, there were design computing and design computation existed at MIT. Our master's was called MSc Computing and Design. So there were all sorts of different terms for it, but not computational design. And the way that I positioned it in order to found that first group I will talk about now, I used to start my talks in Europe predominantly, so between 2005 and 15 roughly, with these 2 slides, where I said, for me, it was always interesting when computational design, because by 2006-07, computational design was then slowly being adopted by other academic outfits. But it was effectively just taken over from parametrics, again, kind of coining that term just to mean parametrics. So it always struck me to say, I used this example, which of these 2 buildings are done by computation? Everybody would say, hooray, the one on the right. And I'm like, great, yeah, that's the Cook and Funnius Kunsthaus in Graz, which was probably the kind of blob architecture, right? This parametric super example. And the one on the left, of course, too boring, you would think. Of course, I can't be computing, yeah? It's not crazy enough. But the one on the right, then, if you look inside, is actually very, very simple. It's just slabs connected by stairs and ramps. So that's all it is. And the one on the left, which is actually an office building, is very complex. It's super complex internally. And I always ask myself the question, why do we want to use computing just to have crazy shapes and generate shapes, but not really think about what the essence of architecture in a way should be, is the human use. And that building on the left-hand side is much more complex than the building actually generated through computing. So, of course, it struck me always at the time that this idea, at the time, everything was still to do with computing shape, computing or generating shape, form finding was called parametric modeling, as you know. And in a way, the diagrams were always strangely, we said to our students at university, don't build the diagrams. But it seemed to me very much in the parametric community, the diagrams were always built. So that the function had to follow the form, and even more so the software, because quite often practices and studies in parametric modeling were often based just on softwares that were available. So on the Bézier kind of curve generation, or even nowadays, if you see sort of agent-based modeling, finally the software is available, people are starting to use it, but then the buildings that are developed from it still look almost like exactly the diagrams so the software generated. So it's always struck me as a bit of, maybe grasping too short and not going far enough, and not looking enough at the people in that picture. And I thought computational design should be about design, computing design, and design means really designing for people. And therefore phenomena that arise from dynamic conditions really follow the use of configuration, use of spatial configurations and structure organizations. Like these 2 ladies who found themselves a spot between 2 parking cars because they couldn't find it in the restaurant. So they interpreted the scene and behaved accordingly to what the space was offering. I happened to be, luckily, in 1999, exactly at the right place, the right time. That was in London, and it was a small school, not very well known, but very high in the ranking at the time, University of East London. And they had the one of the really just 2 or 3 pioneers of computing design at that school, which was Paul Coates. And he'd set up in 1991, which could really definitely be said to be the first Masters of Computational Design, which was called MSc for Computing Design. And he really looked, as opposed to his American friends, who looked more at sort of knowledge-driven design and design automation, he really looked at machine learning and artificial life algorithms. He really wanted to develop algorithms for doing sort of self-organizing spatial organizations. And he introduced and invented quite a lot of the cellular automata and 3D for spatial design, linear systems, genetic programming, all of that he actually took from the computing science community and adopted it into architecture. And in 2000, I joined him teaching, and I introduced a lot more than some of the AI models, but also machine learning models. So Pablo Miranda-Granza invented the swarm tectonics, so the first proper swarm model that was at the time. So neural networks I introduced at the time, so the AI models. Lots of cognitive neural agents we even did. It was quite interesting. Lots of ant colony algorithms. We introduced multi-criteria Pareto optimization to architecture and planning. So a lot of interesting things were happening at the time. And it really is really down to these two guys that field really exploded or actually start to make sense. So Paul Coates, the guy on the left, with him, I then founded the Center for Evolutionary Computing and Architecture, CECA, at University of East London 2002, to try to not just teach 4 courses that we had, seminars, lecture series, but also to services into the industry, which I can show one project in a moment. Paul and Bill Hillier died, unfortunately, also in 2019, Paul Ray in 2013. I was lucky to work with both of them, but the interesting thing was that at the time when I came into this field around 2000, the fields were really separated for a long time. So these two pioneers are also kind of pioneers in their silos, if you like, yeah, where they actually sometimes work together. Paul was concentrating machine learning and generative architecture. Bill Hillier and others at UCL were concentrating on spatial analytics, if you like, yeah. He invented space syntax, Bill Hillier, in 1969. When it was actually originally a generative theory, but eventually then turned towards understanding how they could be validated. So you always really look much more at developing models of validations, of analytics. Yeah? So one of my contributions, I suppose, apart from introducing AI and neural networks to architecture and urban design, was definitely the bridging of that gap. So computational design for me was meant to be then, I kind of used that term then to say there's design and computing is very much analytic as well. So quantitative design is often qualitative, so to bring the two together. So bringing the generative design, the self-organization, bottom-up, distributed systems, and machine learning algorithms from Paul and taking Bill Hillier's idea of a theory of architecture could be quantified through a syntax that is very much people-based, bring those two together into a field for design, for designing with, so design processes. And that's what I meant with computational design at the time. And hence we then used that word computational design to found the group at Aedas in 2004. And I made sure at the time as well that because the Foster Smart Geometry group existed, SMG already, so everybody thinks that's the first computational design and profession. But of course they did parametrics, they resolved geometry by somebody else. Yeah? So the key parametric domain, so either generating shape and resolving it, so rationalizing it. And I set up also under the Aedas R&D initiative another group which only dealt with geometry and parametrics. We called it the Advanced Modeling Group. And set up the Computational Design Group as a separate group just dealing with machine learning, spatial analytics, and design processes. Yeah, and I'm going to talk about, just to review in a way, some of the early projects from that domain. And of course, it was a golden time because computational design and algorithms didn't exist in the industry per se yet. CAD existed, but that was just about it. And so in that way, we were embedded into Aedas. We could effectively choose projects and do and apply ourselves to whatever we wanted. And since there was no best practice at all for solving any of these tasks and for systems, we could set up the systems ourselves. And some of these, and I have to say, these golden time in a way was really quite amazing. And we're a small team, really. Usually we're about 5 people and then somebody coming in and out, but we're really just the people there that you see at the bottom that helped to develop all that work, which were sort of all the foundations of computational design, especially in the spatial domain, spatial organization, generative design that is coming through nowadays in all these different domains and sectors. And in 2008, for example, Autodesk invited us 2-3 times in a row, but 2008 was the first time, which was the inaugural Design Computation Symposium, where then the CEO took our material to talk in front of the keynote that he gave in front of 25,000 people. He hadn't told me, he used our material to demonstrate and launch computational design, or launch generative design into the future. And I didn't know that he was going to use it. And even that brochure here in the background is one of our projects. That was also in the Middle East, that project. So the stuff that you see from Autodesk now was sort of kicked off then through a lot of the foundations that this group had done. And similarly, so Wired reported about the work that we've done, sort of changing the way that architecture works, all quite early. So it's just a small bunch of people. And we did projects like this. This was actually not even with Aedas. That was sort of this SICA working. I set up a professional education course, a degree for computation. And we had all these professionals. So it was a short evening course, only for 12 weeks evening course. And we had all these people come in from Foster's, from Arab, from Hadid, from SOM, coming to learn how to script, how to write basic algorithms, with me. And so we invited them once by 2 project leaders by Hadid who were in that course to do the computation for that project, 2006, and which was then their first official proper computational design and machine learning, because I then programmed, we had to come up with a concept for Piper Heidsieck headquarter competition, came up with a concept of the riddling, the production of champagne, how it's being produced. And we had the accommodation schedule and adjacency diagrams, and translate that into a self-organizing feature map, so a self-organizing unsupervised neural network, produce the software and the interface, the whole plugin for AutoCAD, so they could then plug it into their system at Hadid, and they could then, using this underlying neural network generative process, they could generate their own designs by tweaking the geometry, but also tweaking the adjacency diagram, accommodation schedule, how kind of hierarchy of the organization relates into different types of rooms. And that worked, and they eventually, based on some solution, they rendered it or basically worked it out, rendered it and submitted it, and it won second prize. So it didn't win, but it was second prize. So it was a very early sort of AI, artificial neural network for design at Hadid, under the hood, so to speak, because I think the leadership wasn't quite aware of it. And of course, in 2007, it's an interesting also if there's a lot of students now listening, it's a quite interesting project because it became so big, the project, and that's in the Middle East, in Abu Dhabi, the Bahr Towers, which was originally Abu Dhabi Investment Council, ADIC. And it has a history where we, in the end, weren't really involved anymore, of course, in translating this. But it's interesting that in 2005, I ran this workshop at the University of East London at SICA. I organized the workshop. My colleague Pablo Miranda taught it with me. And we came up effectively with a prototype for the facade in terms of not the geometry of it, but the way it worked. So we had these sensors and actors that we used to facade elements with the students, and it worked quite nicely. And one of the students then came to Aedas, and he was then designing the project based on that knowledge and brought us in. And we then developed the simulation for the facade and resolving the geometry and how the facade will respond to different environmental conditions, which won the project and won us also this CTBUH Award for Innovation in 2012. And this is, for us, I think it's a groundbreaking project, the September 11th Memorial Museum in New York, where we received the drawings of this ramp, right? And so basically from up here, you come through the Snowhead reception area or visitor center, you go down to the ramp, And then eventually you end up between the two tower footprints. And all sorts of experience are meant to happen on this ramp as you walk through the space. But they didn't know how to tweak it properly, how to control it. And we then took the original sort of Alistair Turner's 2D visual graph analysis idea, right, and translated it to 3 and 4D. So you could actually see as somebody moves through the ramp, how the experiences would change based on introversion of space. Do you want an exhibition space or extroversion of space? All measured through movement and visual condition. And we broke everything down into 1 square meter, 1 cubic meter parcels or cells that would all be evaluating the space and the movement of the people through it. And it's, I think, an early example of big data when there was no big data. So we didn't have any data, so we had to generate it, and then we'd interpret it and then design the ramp from it, tweak the ramp or the parapet. So when do you see what, who moves with whom? So also this year, this project then won the RIBA award for research and practice in 2010. And this project, finally, the last of the early projects, so to speak, uses a graph search algorithm or a multi-threaded graph search algorithm, because I had to do parallel resolve depth of graph growth and traversal in parallel, and achieve certain goals so that all these furniture pieces would be linked together and have maximum horizontal surface area for books and other things to place. And we then even then in 2008 used some WebGL technology that we could actually put it on the website of the furniture producer, MDF Italia, so that the users, without knowing, were guided by this algorithm to produce outcomes that are part of the branding of this design, but the users would produce their own design. Everything underneath was calculated in terms of connections for electricity, depth, support structure, the cost, etc. And then a file was sent to their SAP system if the user decided to buy a certain piece, and 2 weeks later they would come and install it. So it was a really early, as Interni, which is sort of Italy's big interior design magazine, wrote in 2009. So this was the big, it was actually 2008 that they wrote it, was the big Design 2.0 at the time, development and furniture design, for which we then won a Premio Compasso d'Oro, which is every 4 years the furniture fair in Milan gives prizes for categories, and that won for shelving systems that won the award. So that was sort of the background, and but a lot of work really from the beginning when I did my master's. I was in the urban domain, and there were, of course, also big precedents in that case. So Cedric Rice Fun Palace that he evolved with eventually into the Generative project, with John Fraser joining him, who worked with Paul Coates before, and that combined set up a company in 1981, John Fraser and Paul Coates, to try to sell generative CAD software, which then failed in the early 80s because it was just too early. John Fraser, with his wife Julia Fraser, built the software that could basically be like a self-organizing structure, computed structure. And Gordon Pass called it computing without computers at the time. Similarly, there was another development, of course, which was really big. Is so starting with the informal settlements, which Rudowski wrote this book about architecture without architects. And of course, in Egypt, you had Hassan Fatih, who himself wanted to enable locals to build their own cities, to build their own houses and make their own cities or villages with New Gurna. In a way, such a settlement that Bill Hillier developed the space syntax software or theory around. And Paul Coates, in fact, was the first guy who then wrote the first software based on space syntax, using initially a kind of cellular automaton to develop that, which he then later developed more into an alpha syntax software, he called it, which was one of the space syntaxes to really reflect more sort of Arabic settlements. So there were all these developments of planning without planners and architects without architects and even computing without computers at the time. So it inspired this idea of the self-organization. And My then master's project I had to go to libraries at the time. There were no libraries, there was no Grasshopper, there was nothing. So you had to go to libraries, get the math book. And I heard about these neural networks, and I heard about Cajon and self-organizing map, which would organize information autonomously. So I tried to spatialize that, so turn to 3D. And that worked, and used a site, which was King's Cross, as my input. So I built a model that would then pass the site step by step automatically by itself, and based on the information it would find, as you can see down here on the right-hand side, would actually drag along and walk around the site and classify effectively the experiences per generation of learning. Yeah? So we then eventually mapped all those individual places into larger so maps. But later we went further, also more development at CECA with students, where we looked at more adaptive topologies, growing neural gas algorithms that could actually generate their structure according to the input signal space much more independently, and used also already things like social network theory. That was even before Facebook, I believe. That we used social network theory with our neural networks together in order to look, for example, this project here in London, at the activation by the community of the street. And part of the social network theories is clicking, so you can see what type of communities using the street at what time. So you could build correlational networks between the street itself, the shop activation, the types of users over time. It was a quite interesting classification model. And further, so we then implemented more and more slowly into actual projects with another student. I worked with the 4M group in 2006 to 2009. We did multiple projects, but this one I think was the most interesting one. We did agent-based models, and this one was a big master plan called the Eng complex, which is actually under construction still, where we developed the first Pareto optimization model for urban design, using ant colony algorithms to generate the ground partitioning through the connectivity of the city and the amount of space that's meant to be left over as footprints of certain ant users. That was quite impactful, but then eventually really the biggest project in terms of research, the beginnings, was in 2006. We applied in 2007, we won this Urban Buzz Fund, which is a higher education fund in the UK. And we worked together with multiple urban planners, with councils, UEL, so the CECA and the Aedas Computational Design Group together to try to develop a digital chain for generative urban design, which went across multiple scales, from GIS all the way to massing and evaluation models for the massing. So all working along sort of the design guidelines of the time for best practice in urban design. So we could actually generate whole master plans, pretty large master plans on site, inner city sites in London. Yeah, so it went predominantly across the scales of sort of the whole circulation diagrams to land use distributions and the massing generation, which is again, so massing generation, as you see on the right-hand side, is what you see now as startups coming up. Yeah, 14 years later, sort of SpaceMaker and others are sort of just doing these massing generations as their business model, without even doing sort of the initial structuring of space. That needs to still be, nowadays, be fed in manually. But that software was like a software open framework with multiple software pieces. Was then also Foster's wanted to buy it, but we didn't have licenses to sell at the time. And Arab trialed it. So we had multiple kind of companies trying to buy or license the software from us to do their urban design. But we kept using it internally at Aedas because we couldn't really build it out through into a fully marketable software, scale it to that degree as a small team of 4 people at the time, and doing projects simultaneously. And then eventually, nowadays, I can see that these were the beginnings, becoming increasingly called computational planning, I believe. So that type of generative urban design. And so I wanted to kind of slowly progress through the generative urban design world as well. But in the meantime, that change happened as well. So at the end of 2014, my group was moved from Aedas as Computational Design Group, or Computational Design Research, we also call it, to with Bagot, where we call it SUPERSPACE. And an interesting change in a way happened because at Aedas, as I mentioned earlier, the golden years, we could do and apply ourselves very freely to do and apply and develop any algorithm that we saw fit to any kind of scale, as you could see, from furniture to whole cities. But at Woods Bagot, we concentrated a lot more and worked a lot closer with the sector leaders, where we then said, okay, we're a cities and places sector, transport sector, and especially within transport, then we had even aviation models that we developed specifically, rail models, we had retail models, specifically only for retail design and malls environments. Workplace, we built a whole plethora of 12 tools that were developed into framework for workplace design only, and user simulation models that, of course, work across multiple scales, but we predominantly use these simulations for urban and retail modeling and aviation increasingly. But now, of course, I keep concentrating on cities. I can talk some other time about all the other models, but now I just stick with the cities. This was still at Aedas. What I want to say is that more the commercial work starting to emerge. And of course, I'm also selecting some projects that have to do with ASCAAD, if you like, and your region. So in 2009, apart from, of course, Foster's with even Space Syntax Time, developed the City Master Plan. But we were then also called to review it under Aedas. Aedas developed one of the neighborhoods called MIST 340. And we evaluated the overall master plan structure in line with sort of the transport or the mobility principles of, so you have light rail transport coming in, then you have some station from where you can jump into these personal rapid transport capsules, and then you're always meant to walk within 2 minutes to your front door. So these 3 scales of mobility effectively, yeah. You can see very nicely the models that we then developed for ourselves that spit out also the hierarchy of place and the privacy of places. And yeah, as I mentioned, sort of then scaled from the city down to the blocks that were developed by Aedas as well, into then the individual, into the blocks and to the each front door, and then the experience and the shading within these paths, within these blocks as well, where we developed a sort of automatic depth algorithm for the windows so that it's rightly shaded inside as well as outside in the alleys between the houses. And that type of principle, in a way, of that normal spatial analytics, we applied also to many other projects in the Middle East, particularly as well, but also to the Expo 21 in Dubai that's coming up. I don't know, I think still coming up this year. And initially the master plan wanted to have these pedals here, which were villages in their own right. But there were 2, so we did the evaluation optimization of the spatial experience, if you like, of these village petals, and we found that they were too tightly designed, so you couldn't really find your way through properly and understand its place properly. So we helped to unclutter them a little bit through the analytics that we did. So we developed whole models for this as well, again, where you can do which you can see on the right. So the movement and views in 2D, 3D, the whole experience effectively across multiple scales that you could work within a single software. Yeah. And then eventually this idea of doing, on the one hand, generative, on the other hand, analytical, got more and more fused in 2013, still at Aedas. Then we developed for the Expo 17, the green blocker was called. So exemplary village of the Expo. We developed a whole process, again, a digital chain, which then proved to be the exact right thing to do, with, as you can see here, 9 different steps of development, again, from distribution of land users to the generation of circulation, the breakdown of the plots, the massing. And you can see here that was sort of the beginnings, I think, of some of the Rhino models. Ladybird and so on start to actually come up slowly in 2013. And to do environmental analysis. And we developed this digital chain again at the time in order to react quickly to the change in scope. And that was exactly what won eventually the project, because they didn't quite know where they're going to put the site. So us having not necessarily designed a final output, but a process, was exactly what the client at the time wanted. So therefore, you can also see that this was the outcome that was submitted based on this process, but the process was really submitted to them. So we were very careful then. We submitted videos effectively, predominantly, that show the dynamic of the process and the flexibility of it, rather than just concentrating on the outcome. And the outcome eventually, as you can see, with a very different site, was very different, but the same process was applied. So that was the winning end, the reason why it won. And eventually then in Sydney already at SUPERSPACE, we start to come more and more into inner city sites. And there was this wonderful master plan that we did participate as a competition, very brief, just 4 weeks we had at the time. And we used all these different steps to analyze the whole city, you know, how people would flow and get there, to create sort of sensitive transition through perceived enclosures and densities and exposures, and then generate all these different outcomes. You know, we started with the Berlin block in order to create density for a new typology of users in Sydney, and then eventually managed to break down that density into a different typology, because it was perceived that you wouldn't be able to provide that low scale density in Sydney, because in Sydney density worked very differently up until this point. It was always plinth and tower, but not these kind of courtyard typologies, right? These perimeter blocks that we then introduced here, and managed to keep the towers actually quite low, and overall more of an urban street scale density was introduced, which we refined for every single place within the master plan, and every single apartment was figured out. So it was interesting that within 4 weeks of that generative process, we could go from the whole city connectivity all the way into each apartment. And that project then catapulted us also within with Bagot into more and more projects, and into this sort of generative domain. And we developed more and more software then within Bagot to support larger urban design projects. But we initially, however, we started to do benchmarking. So whenever there was a project, we did automatic benchmarking. So if you had a precinct, or they call it precinct in Australia, which is like an urban or quarter, a quarter that's meant to be health and innovation, and we automatically quantified health and innovation precincts around the world, created a guideline effectively for the benchmark values of how they should perform, how they perform in best practice, created the evaluation framework behind it, created a generative software for the designers, that actually the benchmarks would be fed in, the site could be generated, and the evaluation framework would sit over it, right, to see what the outcome would actually produce, which you're seeing up here. And then the urban designers refined that and cast it into a master plan. Now, what you see up here was a bit funny, that cloth that's thrown over it, because one of the clients, the mayor of this town just south of Shanghai called Feng Zhan, he insisted that eventually his town should be sort of related to water, because it was close to the sea and there was a river going through it. And that basically in section you should see that the master plan should almost look like a wave. So we basically created that representation over it so that he could design, or the designers could see if wave-like density would come out underneath, which is a bit odd, sort of roundabout way, but it was such an explicit request by the client, by the mayor, Feng Zhan. And eventually a project that you might be familiar with in Dubai, where increasingly, as you can see, becomes maybe more and more detailed. And for the Dubai World Trade Center, which was apparently the first original site of the CBD of Dubai, right? We were asked directly by the client at SUPERSPACE to help drive it through evidence base and analytics. And we then proposed, okay, the way that we do it is, of course, look at the context first, understand the context, and then cast it into a master plan, understand the qualities, and try to work with those qualities of the traditional place, the vernacular, if you like. So we analyzed Dubai in some detail, but also its sections, its connectivity of different similar towns, where the vernacular is given and perceived to be a good response to the climate clearly as well, and develop this master plan, which with a kind of contemporary typology of an exhibition center, because on DWTC stands originally that still is the exhibition center, the big exhibition center. And we try to disaggregate this big box exhibition center into a seam, we call it, that would stitch together two types of vernacular urban structure. So it would be much more of a connection within town that could be activated at different levels and slowly being transformed from car use, where you access by car, to other types of pedestrian and personal rapid transport, so autonomous vehicle type transport through this stitch. And what's starting to happen then increasingly is that we looked at user profiles and segmentation, understand what type of users are predominantly foreseen to use the site. In this case, was of course quite often is residents, employees, and visitors in this case, because they want to get this ready for the Expo 2021. You can see the master plan had changed a little bit, which is a learning that you have, of course, with large clients, particularly also in the Middle East, who would like to sell their development quite often as a branded piece as well, right? So you can't often be too subtle. You have to be a little bit more selly. But understand the users around the site. And we then created all the different conditions maps around the site, and then looked at how, from the locations of these different users, with the residential, the commercial, the access for transport, the other types of retail activation and lunch, so cafes and third places, how the site would be used by all these different users and how they would actually overlap because of different conditions. So how much diversity and interaction do you create on site, so it becomes actually a worldly place, activated very strongly in certain places and maybe a bit more private around the residential developments. So it was starting to become very user-centric, which at the time the client really very much enjoyed and asked us back effectively. Then again, once they started to detail out in schematic design, the DWTC, so we could do this user profiled simulation again. And hence the next section is about, let me just see what time it is. It's about sort of the users. And that's where big data now slowly comes in. We did this project for the CTBUH in 2007. We said, okay, if you use a city purely from public transport point of view or from a car point of view, you get very different sort of density patterns, which we simulated. So if you build a tall building and you have this type of transport or mobility versus that one, you get one being much more sprawly and low dense, and one being much more tight, and high dense, less sprawling. But it was all about this one type of user, mobility user, just like the work that we did. So which was the first one on big data in a way, 2010. We got the data from Barclay Bikes at the time in London after 4 months or the first 1 million journeys. And they didn't tag bikes, so they only tagged basically, you had the docking station data, which bike was checked out where and where was it checked back in. And so we did the research on how cyclists actually behave and choose routes. And then we could re-simulate for every minute through the data set all the probable routes back into London. And you could then create, of course, the connectivity between neighborhoods, how the streets were used, and where you would actually allocate from planning point of view what type of infrastructure for the cyclists. That was a big sort of big data start. And increasingly, then we came to mapping actually users into cities, or mapping the relationship between users and cities. So we started to set up a project called Civitas, where from a civic point of view, you understand the city and plan it around the citizens or the community, where in New York and London, we analyzed all neighborhoods, the whole city, greater New York effectively, broke down every neighborhood, every building within that, and then developed these, you could definitely say sort of these these proto prop tech applications for the creative tech sector.
Dr. Christian, hate to interrupt, but maybe another 2 minutes so we can have enough window for questions and answers. Thank you so much.
2 minutes will be very tight.
Thank you so much.
And you can see with that, we then actually supported a whole host of clients to find the locations and reverse engineer the choices of clients, these are the red lines, on their site. So reverse engineer the decisions of why somebody would choose a site, so site acquisition modeling, which went then all the way to the footprints of individual buildings, what type of footprint you need, what type of organization do you have, and which building and which district you should actually be looking at, and what rent you actually will be paying per year across certain floors, because you want to fulfill certain conditions within these for your workforce. Yeah? So that became sort of, I think, sort of the early proto-prop tech at the time, which was then serviced to multiple clients, from which you could do predictions about where different types of users would move within the city over time. So because I have to keep myself short from now on, even more so, we did this on LA. We used machine learning, statistical learning to understand all the relationships between users and sites and places, how people live. So we could actually help planners to understand the problems with planning sites, so site community sensitive densification, how mobility would impact this. Where I'm going to jump in now is that we looked at mobility patterns, parking, how to convert that, how many people could house where. Used a lot of machine learning on what sites would be prioritized, which car parks to convert first into housing or parks in different neighborhoods of LA, and also generate the policy propositions from it. So we're moving increasingly to planning and policy. And this is also, again, I guess, one of those projects which you see that's then become interesting from a, it's like getting the population to actually help plan. So this is an online consultation process that's still live. So you can see how you trade off between car parking or parking facilities, housing, and green spaces. And once you actually have set up your scenario, you can submit your choices and see how everybody actually wants the city to change. What we built in here as well, we can see how it compares to other cities around the US, at least, in order not to shock people, because people think, oh, if you densify LA, it's not going to be my neighborhood anymore. But we always make sure that you can actually understand if it's still your neighborhood. So people in the neighborhoods would actually plan it themselves. If you have no data, it can still be done like we did here in Shenzhen. And what I want to say was increasingly we're planning for all community. So looking at the day in the life of course, increasingly all these design evaluation frameworks globally as well locally speak to this. That's happening right now also with me now as my new team as well in London, where we do it across from the whole city all the way down using AI and classification models to individual streets. And the outlook was meant to be, if I may just conclude here, the outlook increasingly, I used to say that new, of course, models, not the old ones that we neural networks, are using a much more discretized approach to classify predominantly pixels and images. So generative, what we see also in architecture right now, using these type of approaches, all image-based, which is fair enough because the algorithms are being put out there, TensorFlow and what have you, the pandas to Keras to generate picture image-based classifications. So in effect, it really supports this idea of design by Pinterest. And LopeAI did this great project in 2018 to show how you can recognize different housing types. Yeah? And there's other applications by now out there. But it really does discretize, kind of reverse almost the paradigm what we used to have from sort of a traditional society where nothing was connected, yeah, everything was segregated on purpose, to connectionist models. And nowadays we're reversing this where we say, we never thought that was going to be the right approach at the time. So every part of the region of the brain does exactly one thing, where we used to think the inverse was the truth. And there should be the way to go. A city is a massively connected place. And AI kind of goes slowly that way, that we have to think about also in our society, what we think used to be open and closed societies in a way, right? by separating out increasing portions of work that are where AI then works on individual portions. And we see that also with pedestrian simulation models, which are becoming more and more intelligent, room scheduling models and so on, where individual items of a building of environments being optimized in its own right, and then trying to avoid friction with other systems within that. So instead of having a holistic system approach, we're using individual layers of the system, optimize those separately, creating actually in a way exclusive or segregated environments, which is kind of just a word of caution. We had been there, we tried to get away from it. And I think a lot of it has to do with the way that the models are being used, as I said, so using image recognition software. In 2007, we did this project with students actually rolling our own or developing our own deep learning models from multiple SOMs to eigenvectors, Laplacians, to then using growing neural functions or adaptive topologies to develop a deep learning process. And of course, that was 2007, you used some kind of partitioning to develop a experience-based and quality-based layout system that would be able, based on different exhibition schedules, lay out the exhibition space according to experience that could reoccur in a certain place. Having built this entire kind of deep learning model ourselves based on architectural representation, that's really important, not on images. So it's really upon us to try to, students, researchers, to develop AI models that work with architectural representation, that don't just use what a search engine uses or an image recognition model uses, or anyway, so to finally, last slide, because we have to be aware that, of course, there's always two ways to using everything. And the outlook could be there's great projects happening, and predominantly, actually, I have to say at the moment, happening with focus on the Middle East and Africa, of how to use AI technology to empower local communities to plan and improve their own quality of life. As you can see, for example, with that Million Neighborhood Initiative, many, many more. That's run by the University of Chicago in Africa. Because on the other hand, what it's been used for quite a lot, increasingly, is to classify real estate investment strategies across cities. So cities are being, and neighborhoods are being increasingly rated as commodities and tradable assets. And so that could become a problem, as happens around the world at the moment, where living becomes unaffordable because of this approach. And AI could really increase this problem or sharpen it if used that way. And there's been a lot of protests also in Germany, in Europe, in North America, so against Airbnb, the use of AI on their neighborhoods. Yeah? But increasingly, as you can see, these platforms allow control to the local communities or to corporations, one of the two, right? But it's going to be increasingly planning with our planners. Or is it, is a question, right? And some of the work you can see until about 2014, we summarized in this AD edition, Empathic Space. And new publication, we've done more in papers up to recently. So we haven't bundled it yet in one publication like the AD at the time. We can see all the kind of machine learning, also neural networks for multiple different sectors we described in there. And that's where I leave it now. I think we have another 10 minutes or so.
We have about 5 minutes, and thank you for your time. This was a great informative presentation. There are so many burning questions. I think I'm not sure if you can see them in the questions tab. However, there's a couple of questions regarding the platform and tools best suited for generative design and such type of work. What are the platforms and tools?
So we've always been, me and my team have always been a bit of an outlier here. We didn't use generative components when it came out around 2003 and was used until Grasshopper took over, right? And then Grasshopper, of course, is the platform of choice, or I don't know if Autodesk Dynamo and DesignScript, if that's still around. So me and my teams didn't use that so much. We always developed our own algorithms, and that has to do also with the infrastructure. It partially has to do with the fact that, of course, At the time when we initially learned from around 2000, none of these platforms existed, so we had to develop our own code and repositories. And what we did then, from 2005 onwards, we developed everything in Java because it was much faster than generative components, or still is much faster than Grasshopper. So for bigger projects, we then developed all these Java-based infrastructures, which we used until about 2016 or so, 17, but we still have this massive repository now of algorithms and data structures, which we can go back to and then translate that into whatever required software or development environment we need nowadays, because it becomes a lot more, the infrastructures become bigger nowadays. We have to work on the back end, the database architecture, the back end simulation models, the front end user interface, etc. So all of that becomes, the cloud-based infrastructure becomes much broader. And I think if you were to start, I would definitely still work with environments such, any kind of Python environment right now, where you can have enough information and libraries available. And of course, they're also being facilitated in all development environments nowadays, right. Python. So you can really work very quickly with it. But I guess in larger practice, the difference is, of course, one thing that you do for yourself in academia because you want to do your own project. Another is when you're in practice and you need to develop your whole infrastructure nowadays.
Great. Yeah.
A full stack.
Yeah, I think I agree with you. There's more open platform sources now. Everything is open to customization. There is plethora of tools available now compared to 10, 15 years ago.
Yeah, absolutely.
The second question actually focusing on data. So the question, how do you avoid data bias in your machine learning model? And what are the source of data in most of these projects?
Yeah, it's also a good question, because now looking at this sort of whole span of time, I think around 2012, 13 is when cities made data available. So cities start to curate their own databases that they made public or available to the public into some kind of data stores that cities procure now and curate and provide APIs to them. Well, until then, we had to literally, apart from very few publicly available data sets like OpenStreetMaps was already around before then, but only roughly around then, I think. We had to sort of generate almost everything ourselves up to that point. So, for example, the September 11th Memorial Museum, which of course is a building. So, as I said, you had to sort of pre-process the geometry in order to generate the data that you then feed into your generative and analytical models. Yeah? So you had to definitely always do that pre-processing, the data processing stage beforehand, before you then, even nowadays, of course, that data you're hoping to often get already, then you clean, format, outliers out, etc. You prepare it, and then you work with it. But even nowadays, if you work spatially, and if you want to work on that interface between architecture and urban design or urban planning, a lot of data is not available still, right? So you have maybe some data sets, especially say in Europe and North America, in Australia, you've got a lot of data sets available by now that have to do maybe with census data, maybe even some land use by now, sometimes 3D models that you can use, but you then still always need to pass over it to generate your own data sets that you want to work with because you're working towards a business plan or a target, or a brief. So I used to say about 60% of the data we generate ourselves, and 30 to 40% is publicly available that you can absorb into your own work. To get the bias in or out, we quite often work by also validating the work ourselves with planners or other partners to see that what we generate as a baseline analytics, we could call it the baseline analysis, we then socialize that out with the stakeholders and ask them to rate it and see that we can calibrate our models where basically bias occurs.
Great. Thank you so much. I think we're almost done from this session. It was a very exciting keynote presentation. I would like to encourage all the attendees to interact and seek conversation with Dr. Christian through the Eventus virtual platform. Perhaps we can take a final question here. There
Sure.
was a question about how do you take these techniques of simulation and generative design, computational design into the vertical cities? Is there a way to design a vertical urbanism and connectivity in terms of computational optimization? If you can
I mean, why not? Yeah, I mean, why not? This has been a topic for a long time. So you've got everything's vertical nowadays, or at least sort of the concept of it, right? Becoming sort of vertical campuses, vertical universities, vertical health centers, so many vertical concepts are coming out, vertical communities. So with build to rent, quite often the idea is, the build to rent concept. I don't know if you're aware of that. So in the industry, it's more of a concept, right? Of what we build for whom. And that's a vertical sort of intergenerational community. So there's one thing to say vertical being just a building, and how a community actually interacts within that building. And then there's another, which is a vertical, literally a city like Hong Kong, if you like, is almost like a vertical city, because it operates connected across different layers, right? So all of that has been thought of and has sometimes even been computed. So the project that we did in Shenzhen, which I couldn't really talk about just now, where we didn't have any data, we mapped the data, collected the data with 25 students, and then digitized it, and then did machine learning on it. So there was no data to start with. But these guys, they worked in Hong Kong on vertical cities as well, for example, more of a conceptual level. But we've done all the models that we've done, initially, especially at Aedas still in the beginning with Bagot, a lot of them are vertical. Because, of course, buildings are not, I mean, you don't really have flat, what do you call them, ground scrapers, really, nowadays. You have predominantly skyscrapers, whereas universities or health or offices have complex, like I showed in the very first slides, have complex inner vertical life, to connect different activities and communities and neighborhoods within a building. And that's actually become more the norm of anything horizontal. The only horizontal, purely horizontal projects that we did and simulations that we developed for was predominantly aviation, so airports, airports, and to some extent cities. But even cities, I showed you how the project in New York, we worked actually, so every floor of every building was considered. So you actually had to trade off between all the different floors across the whole city. So that was already vertical in its own right.
Great. Thank you so much. Maybe one last burning question. This is very energetic and interactive. There was a question about how can these ideas be implemented to new cities and the settlements where data is all based on projections? Will this lead to major planning mistakes the same way we suffered from this in the traditional planning? So how perfect is the system?
Let's say, when you say the mistakes of the past, one has to be aware of that, like I showed that DWTC project in Dubai, one has to be aware of that the methods that I'm showing here, that I've been showing, and sort of by now, like the end that unfortunately last sections I couldn't talk about so much, net community benefit modeling, impact assessment, and so on. These methods are super new, and they haven't really been used in planning yet. Not much anyway. There's been no city that's been planned on these processes yet. And even the DWTC, although we brought in all this knowledge, all this possibility, in the end, it's still common. It's still very common that the client says, "Well, I would like to resolve the transport and the traffic jams first." So the mobility of the vehicle takes priority quite a lot still. So unless unless we get this out of our head, so these artificial enforced priorities for planning based on traditional layouts over the last 50 years, it doesn't matter what technology you have. Yeah? It doesn't matter what kind of process you have, as long as the designers and the clients still have this sort of traditional process of starting with a car, starting with trip generation, etc. Right? You can throw whatever you like at it. It's not gonna, it's gonna repeat the same mistakes, of course. It's not. I don't think it's technology dependent. I think it's much more a mindset and an attitude dependent. If you can design good cities or not, it doesn't matter what scale. It doesn't matter if the cities are brand new, because yeah, it's more prioritizing qualities of the city over others, like car traffic. Yeah,
Great.
And I like to say, just also to close off, I think I almost had that slide and then I took it out again. When I started, and I showed 2004, set up the first group there in London. In 2004-5, I started to talk at the first events in London, where also people like Foster's and Hadid were talking. But they were, at the time, of course, they used parametric modeling. It's still pretty much do, but the point was that even the leaders of these teams at the time, from Foster's and others, were saying, oh, no, what the guys from Aedas are doing, we couldn't do that in our practice, because I couldn't see that machine learning, self-organizing systems would one day be valid or valuable to them. Yeah, they couldn't quite see it yet. So I guess for students especially, don't let yourself be discouraged, by others who are now sort of in leading positions and practice and so on, saying, oh, this shouldn't be done. Try it anyway, especially if you have a kind of a good sort of aspirational target with it, like I showed in the end. If you want to kind of improve cities, like the last question, if you want to improve communities.
Fantastic. Yeah. Thank you again, Dr. Christian. This has been a very wonderful presentation material and an overview of your work. Thank you once again. Thank you, everybody.
Thank you, Saki. Thank you very much.
Thank you.
Listening.
Thank you. Bye-bye.
Bye-bye.